Breaking news just shook the scientific world. NASA has discovered the strongest evidence yet of ancient life on Mars. In July 2024, a peer-reviewed Nature publication revealed that Perseverance's Sapphire Canyon sample, pulled from an ancient Martian riverbed, contains mysterious leopard spots and strange mineral traces, unlike anything seen before on the Red Planet. NASA's acting administrator calls this a groundbreaking discovery, and for the first time, experts are seriously asking, are we alone in the universe? But what exactly did Perseverance uncover, and could these Martian rocks truly rewrite our place in the cosmos? Publication in Nature does not come lightly. Over the past year, the Sapphire Canyon findings have undergone the most intense scrutiny in planetary science. NASA's Perseverance team first submitted their data in the summer of 2023, launching a review cycle that drew in geochemists, astrobiologists, and mineralogists from around the world. Each dataset, elemental maps, Raman spectra, high-resolution images, was dissected by independent panels, challenged for every possible error or alternate explanation. Drafts circled through dozens of hands, with reviewers demanding new isotopic analyses, side-by-side comparisons to Earth analogs, and blind cross-checks of instrument calibration. On July 10, 2024, Nature published the peer-reviewed results, confirming that the Sapphire Canyon sample contains mineral features and chemical clusters, unlike any previously cataloged on Mars. Acting Administrator Sean Duffy, in the agency's press briefing, called it the closest evidence we have ever seen for ancient life beyond Earth. His statement, echoed across newsrooms and scientific circles, underscored the gravity of the moment. For the first time, the world's most respected scientific journal gave its stamp to a discovery that could redefine humanity's place in the cosmos. The story now moves from the press room to the rocks themselves, as the evidence behind these claims comes into focus. Perseverance, rolling across the ancient sediments of Jezero Crater, found itself at the edge of Cheyava Falls last July. The rover's cameras focused on a patch of stone unlike any previously cataloged on Mars. Across the rock face, clusters of dark, rounded spots, some no larger than a poppy seed, others merging in tangled chains, stood out against the pale matrix. These were not random stains. Each spot, mapped by the Pixel instrument's X-ray beam, revealed a concentrated mix of iron and phosphorus, the chemical fingerprint of vivianite. In the same zones, Sherlock's ultraviolet laser picked up signals of organic carbon and a second mineral, greigite, and iron sulfide. On Earth, both vivianite and greigite often form in wetlands and river mud, sometimes as a direct result of microbial metabolism. The pairing of these minerals, locked in concentric halos and radiating from the rock's core, drew immediate attention. Scientists noted their resemblance to reaction fronts, boundaries where chemical energy, and possibly life, once pulsed through the sediment. The poppy seed motif, scattered across the sample, echoed textures seen in terrestrial riverbeds where ancient bacteria left their mark. In Jezero's river delta, 3.5 billion years old, these patterns are a visual archive of a world that may once have been alive. Chemical clues from Sapphire Canyon cut deeper than any single mineral. PXL and Sherlock mapped out a suite of elements: iron, sulfur, phosphorus, and organic carbon, all concentrated in overlapping halos. On Earth, this convergence is rarely random. It points to reaction fronts, boundaries where chemical energy once flowed through mud and water, often driven by microbial metabolism. The fine layering in these rocks, among the youngest sedimentary strata Perseverance has sampled, hints that Mars stayed habitable far longer than once believed. Each nodule's core-to-rim zoning, with phosphorus and iron at the heart, and organics at the edge, mirrors patterns seen in riverbeds and wetlands back home. Project scientist Katie Stack Morgan cautions that extraordinary claims demand extraordinary evidence. She notes that while the mineral chemistry and textural context are consistent with life, non-biological processes can sometimes mimic these signs. The story, for now, remains written in the language of chemistry and caution. NASA's focus now turns to bringing the story home. Teams in Pasadena and across Europe are finalizing the Mars sample return architecture, a single lander, a two-stage ascent rocket, and a European-built orbiter, all designed to ferry up to 26 rock cores from Jezero Crater back to Earth. Engineers track each cached tube, ensuring Perseverance's precious cargo stays safe through Martian winters and dust storms. The Sapphire Canyon sample, with its leopard spots and poppy seed textures, sits among them, sealed and waiting for a journey no Martian rock has made before. Once on Earth, these cores will face the cold framework, the context likelihood of life detection scale. This system grades every clue: chemistry, structure, context, and the elimination of non-living alternatives. Only the strongest evidence will rise to the top. Meanwhile, NASA's human exploration teams are already testing new spacesuit fabrics in simulated Martian dust, preparing for the day when scientists themselves will walk Jezero's ancient riverbeds. The next chapter in the search for life is already in motion. In July 2024, NASA published its findings in Nature, confirming that Perseverance's Sapphire Canyon core contains minerals like vivianite and greigite, substances often linked to microbial activity on Earth. The detection of organic carbon, sulfur, phosphorus, and oxidized iron in these Jezero Crater rocks provides the most compelling evidence yet of potential ancient life on Mars. However, scientists, including project scientist Katie Stack Morgan, stress that extraordinary claims require extraordinary evidence. The true origin, biological or geological, remains under investigation. 26 Martian rock cores, including the Sapphire Canyon sample, are now slated for return to Earth, where advanced laboratory tests will apply the CoLD framework and rigorous standards of proof. With Mars sample return planned for the late 2020s, humanity stands at the threshold of possibly answering one of its oldest questions. For now, the evidence reshapes our understanding of Mars history and keeps the search for life beyond Earth alive.